So here you learn from me about Meso compounds. Right. What are Meso compounds? The definition means that you have a molecule with more than one chiral centers, but there is also an internal plane of symmetry within the molecule. Now it's always easier to use molecules and drawings to describe an organic meaning. So here you see a cyclohexane hydroxy group branching out from the first and the second carbon here, and take note of the shading I'm using right here. This means these are the wedge bonds. In organic stereochemistry, wedge means going towards you. These carbons here are sp3 hybridized, so that means you have a 3D formation. So it's not planar. Now this bond is not planar, but rather it goes 3 direction. So this means OH is pointing at you. You see my hand here? It's at the angular form. It's not flat at the board here, right? So both these OH group are pointing towards you. That's what it means. Let's examine that these carbon are chiral or not. So 2 fingers up again. OH, H, first junction, C connected to HH and carbon, a C connected to OH carbon. So these 2 paths are different, and hence all 4 surrounding this carbon are different, and this is chiral. Put a star here, and if you do likewise, it's the same for the below, and it is also chiral carbon. But now you realize that there is an internal plane of symmetry over here. I can draw a dotted line across, and you see there's a reflection. There's a reflection. And so this is what we call the plane of symmetry that exists in the molecule. And if you have this within the molecule, by definition, the molecule is achiral. Achiral means not chiral, right? So please mind your language and listen carefully. This is an achiral molecule. So that means this molecule is achiral. That means it's not chiral. And when you have a molecule with more than one chiral carbon, yet with a plane of symmetry inside, we call this a Meso compound, which is achiral.